Hello and welcome back. In this video, we will be conducting a two-way analysis of variance, or otherwise two-way ANOVA. One of the previous videos we have conducted one-way ANOVA. And what was the procedure there? In one-way ANOVA, we had one metric variable as dependent variable and one non-metric variable, categorical variable, as independent variables. And that categorical variable must have minimum 3 categories. In two-way analysis of variance, we will have one dependent variable, that is metric variable, and two or more than independent variables that are categorical. Here there is no specification with respect to the category of a particular categorical variable, but we need to have minimum 2 categorical variables. If we have one metric dependent variable and 2 non-metric independent variables, the analysis is called two-way ANOVA. When we have one metric dependent variable and 3 non-metric independent variables, it is called three-way ANOVA. Like that, when we have one dependent variable, metric dependent variable, and n number of categorical variables as independent variable, it is called n-way ANOVA. So what we do in two-way ANOVA, that is the simplest form of n-way ANOVA, we will be examining whether 2 categorical variables will have some combined influence on the dependent variable that has been expressed in metric form or ratio scale, that has been measured in ratio scale or interval scale. What is the null hypothesis here? The null hypothesis is there is no combined effect. Let's recall the 2 questions: whether the test is suitable for that. Second one, whether the data at hand are relevant. The test is suitable. What is the purpose? The purpose is to examine more than 2 independent variables will have a combined effect on a dependent variable. That dependent variable is measured in metric form or parametric variable. What is the test for that one? The test is a modified form of ANOVA. So previously we located one-way ANOVA from compare mean and we selected one-way ANOVA. But here we will locate general linear model and select univariate. In univariate, we have one dependent variable here. The dependent variable must be metric variable. So we will be using the same variable. How long have we been using the internet cafe? That means the duration of using cyber cafe. What are the 2 dependent variables? The two dependent variables we will identify from this database as gender and marital status. Gender and marital status we will load together. That means, so having got this dependent variable as the duration of a cyber cafe visit and the independent variable as gender and marital status, both are nominal variables. And what does it mean? Let's customize our hypothesis. There is no combined effect of gender and civil status on the duration of internet usage. Let me repeat. There is no combined effect of gender and marital status on the duration of cyber cafe visit. That is the null hypothesis. Please remember there is this null hypothesis till the end of our analysis. And from this one, we will click the radio button model, since we have to check that whether it is custom or not. By default it would be full factorial, but we have to change it into custom, and we have 2 variables here. We will select these 2 variables, and what does it mean? This test the combined effect, and at the same time the test will allow gender or any one of the variable to perform its impact, keeping others controlled. For example, when gender is allowed to perform, marital status would be controlled. When marital status is allowed to perform its effect, gender would be controlled. That's why to allow that, we have to load these two variables on the model. We have to load it one by one. Okay. It should be main effect. We have to select it main effect. Then continue. Yes, we have got the result. This is the result. Let me magnify this. Yes. So the corrected model, look at the first line, first row, the corrected model. Corrected model gives us combined effect. The combined effect, what is a null hypothesis? There is no combined effect. And whether that null hypothesis can be retained or not, we cannot reject that null hypothesis. The null hypothesis, there is no combined effect by gender and marital status on the usage of cyber cafe, and that null hypothesis cannot be rejected since the significance value associated to the F statistics is higher than 0.05, that is above the threshold value. So we have to retain, or we fail to reject the null hypothesis. So when we fail to reject this null hypothesis, do you know what is the conclusion? The conclusion is that there is no combined effect. Then, having understood there is no combined effect, then we will be curious to know that whether individually they have some effect. Look at the value, F value against gender. The F value against gender is 4.066 and its associated significance is 0.044. This means that the significance value associated to the F value of gender is less than 0.05, that is below the threshold limit. So we reject the null hypothesis. That means gender has an effect. So what about marital status? Marital status, the F value is 0.936 and its associated significance is 0.334. So significance value is far higher than the threshold value of 0.05. So here we cannot reject the null hypothesis. So that's why even though individually gender, when it is controlled by marital status, has an influence, when marital status, when it is controlled by gender, doesn't have an influence, then what about combined one? The combined effect also shows that there is no influence. So what we have learned in this hypothesis test, we were testing, or we were examining any two categorical variable will create a combined effect on a metric variable, or otherwise any two categorical variable can jointly influence or impact upon a metric variable.